Welcome to the Oracle's Rest, a place where stories unfold slowly, where time softens, and where the mind is free to wander. Tonight, we descend beneath the surface of the ocean into a world older than memory, deeper than mountains are tall, and darker than night itself. The sea covers most of the earth, yet humans have explored only a small fraction of it. Far below the waves, beyond sunlight, beyond storms, beyond the reach of ordinary life, the planet begins to feel unfamiliar. There are valleys deeper than entire mountain ranges are high, underwater cliffs larger than continents, and trenches so deep that if Mount Everest were placed inside them, its peak would still remain underwater. For thousands of years, humans believed the ocean had no bottom at all. Ancient sailors imagined endless darkness beneath their ships, a world where sea monsters drifted through black water, where giant serpents coiled beneath storms, and where entire civilizations disappeared beneath the waves. And in some ways, the truth turned out to be stranger than the myths, because the ocean is not simply deep. It is the result of an ancient and violent planet, a world still moving beneath our feet, still cracking, still reshaping itself, even now, long before humans existed, before forests, before mammals, before the first fish ever swam through the sea. The earth itself was forming. In the beginning, the planet was not blue. It was a sphere of fire. The young earth was covered in molten rock, its surface bombarded constantly by asteroids and debris left behind from the formation of the solar system. For millions of years, oceans could not exist here. Any water that appeared would instantly boil away into the atmosphere. But slowly, over immense stretches of time, the planet began to cool. Volcanoes released enormous amounts of steam, gases, and vapor into the sky. And eventually, as temperatures dropped, rain began to fall. Not for days, not for months, but possibly for thousands of years. The first oceans may have formed from endless ancient rainfall, water gathering into low places across the cooling crust of the earth. Some scientists also believe additional water arrived from space itself. Tiny, ice-rich asteroids and comets may have carried frozen water across the early solar system, delivering part of the oceans that still exist today. And slowly, the planet transformed from black volcanic rock to a world of oceans, Even now, when astronauts look down at Earth from space, the oceans dominate nearly everything they see. The Earth is often called the blue planet because water covers more than 70% of its surface. But the oceans are not shallow layers spread evenly across the world. The seafloor is not flat. It is broken, folded, cracked, and scarred by forces deep within the planet. Beneath the ocean are mountain chains, longer than any on land. Vast volcanic ridges, canyons, cliffs, trenches, and enormous plains stretching across darkness. Some underwater mountains rise thousands of feet from the seafloor, yet never break the surface. Others eventually become islands. Places like Hawaii began as underwater volcanoes rising slowly upward through the Pacific Ocean. In fact, most of the Earth's volcanic activity happens underwater, far below the waves. The planet is still building itself. The reason the ocean becomes so deep begins with the movement of the Earth's crust. The outer shell of the planet is not one single solid piece. It is divided into enormous sections called tectonic plates. These plates drift slowly across the surface of the Earth, moving only inches each year, about as fast as fingernails grow, but over millions of years. Those tiny movements reshape entire oceans. In some places, plates pull apart from each other. When this happens beneath the sea, molten rock rises upward from deep inside the earth. This process creates underwater mountain chains called mid-ocean ridges. The Mid-Atlantic Ridge, which runs beneath the Atlantic Ocean, is one of the longest mountain ranges on Earth. Yet almost all of it remains hidden underwater. In other places, tectonic plates collide, and this is where the deepest parts of the ocean begin to form. Sometimes one plate is forced downward beneath another, slowly sinking back into the Earth's mantle. This process is called subduction, and over immense spans of time, it creates trenches, long, narrow wounds in the seafloor, the deepest places on the entire planet. The Mariana Trench in the western Pacific Ocean is the most famous example. At its deepest point, known as Challenger Deep, the ocean reaches nearly 7 miles downward, almost 11 kilometers deep. The pressure there is almost impossible to imagine, more than 1,000 times greater than the pressure at sea level. If a human body were exposed directly to it, it would not survive even for a moment. And yet, life still exists there. Small, pale creatures drift through darkness. Strange fish move through black water, and microscopic organisms survive in conditions once believed impossible, all beneath a weight of water so enormous that sunlight itself cannot reach them, because light does not travel forever through the sea. As sunlight enters the ocean, it begins to disappear. The colors vanish one by one. Red fades first, then orange, then yellow. Eventually, only blue light penetrates deeply enough to remain, and deeper still. Even blue disappears. Below a certain depth, the ocean becomes permanently dark, a place where no sunrise has ever been seen, no moonlight has ever reached, and no human eye evolved naturally to survive. The deep ocean is sometimes called the midnight zone, an endless black environment where creatures create their own light. Tiny flashes, pulses, glowing trails, a language of bioluminescence drifting silently through darkness. Some animals use light to hunt, others use it to hide, communicate, or attract mates. In the deepest parts of the sea, light itself becomes rare and precious. And despite all modern technology, humans still know remarkably little about these depths. We have mapped the surfaces of distant planets more clearly than parts of our own seafloor. Large portions of the deep ocean remain unexplored even now. Unknown landscapes, hidden trenches, unseen species, entire ecosystems existing quietly in darkness, far below the movement of ships and storms above. And perhaps that is part of why the ocean feels so mysterious to us, because deep beneath the surface, the earth still contains places almost untouched by human presence, places where the ancient planet continues on, silent and unseen, while above the waves, civilizations rise and disappear beneath the passing of time. Far below the surface of the ocean, beneath the movement of waves, beneath storms, beneath ships crossing quietly from continent to continent, the deep sea continues in silence, cold, dark, and unimaginably vast. Most humans experience the ocean only at its surface, sunlight reflecting across moving water, the sound of waves breaking against sand, the feeling of salt carried through the air. But the surface of the ocean is only a thin boundary layer, a small illuminated ceiling above a world that descends for miles. If all the land on Earth suddenly disappeared beneath the sea, if every mountain and continent sank away, the planet would still be covered by an ocean more than a mile deep. That is how immense the oceans truly are. And despite appearing calm from above, the sea is constantly moving, not only at the surface, but in enormous, invisible systems beneath it. The oceans possess rivers within themselves, currents that travel across the planet, moving heat, nutrients, oxygen, and life itself through the water. Some currents are warm, carrying tropical water toward colder regions. Others descend into darkness near the poles, where icy water becomes dense enough to sink deep into the ocean. This slow planetary circulation is sometimes called the global conveyor belt, a continuous movement of water connecting nearly every ocean on Earth. Some portions of this circulation take hundreds, even thousands of years to complete. A single drop of water sinking into the North Atlantic may not rise again for centuries. The deep ocean, therefore, contains ancient water, water that existed long before modern nations, before industrial cities, before electricity, before humans understood what the ocean floor even looked like. In some places, deep water drifting through darkness today may have last touched the atmosphere during the Middle Ages, while kingdoms rose and disappeared on land. That water continued moving slowly through silence, and the deeper the ocean becomes, the stranger its environment grows. Temperature falls rapidly beneath the surface near tropical beaches. Surface water can feel warm and alive, but deeper down, the ocean becomes cold enough to resemble near freezing space. Most of the deep sea remains only a few degrees above freezing, an endless, dark cold preserved beneath the warmth of the sunlit world above. And unlike lakes or rivers, the ocean is layered. Different temperatures and salt levels create invisible boundaries throughout the water. Some creatures spend their entire lives above these layers. Others remain permanently below them. There are regions of the ocean where animals may never encounter sunlight, even once from birth until death. And yet, life adapted to these conditions long ago. Over immense evolutionary time, deep sea organisms transformed themselves into forms that appear almost unreal to human eyes. Many possess enormous mouths, transparent skin, expandable stomachs, or eyes designed to detect the faintest possible light. Some fish evolved needle-like teeth because food is so scarce in the abyss that any opportunity to eat must never be wasted. Others drift slowly to conserve energy, moving through darkness with almost no urgency at all. In the deep ocean, survival rewards patience. Because food falling from above is rare, the surface ocean, filled with sunlight, produces most of the marine life humans are familiar with. Tiny organisms called phytoplankton float near the top of the sea, using sunlight to create energy through photosynthesis. These microscopic organisms are among the most important life forms on Earth. Not only do they support ocean food chains, they also produce a large portion of the oxygen humans breathe. Much of the oxygen filling the atmosphere at this very moment began in the ocean, invisible life drifting quietly beneath sunlight. When organisms near the surface die, their remains slowly sink downward through the water. This continuous fall of organic material is sometimes called marine snow, tiny particles drifting endlessly toward the seafloor. Dead plankton, fragments of shells, microscopic waste, bits of decaying life. To creatures living in the abyss, marine snow is often the primary source of food. A slow, constant snowfall descending through darkness. In some deep regions, animals may survive entirely on what drifts down from worlds far above them. The deeper the ocean becomes, the slower life often moves. Energy is precious there. Some deep-sea fish may live for decades while growing very slowly. Certain species survive in environments so stable that change itself becomes rare. No seasons, no sunrise, no weather, only darkness, pressure, and cold. Yet even in these depths, the seafloor is not empty. Far from it. The ocean floor contains enormous landscapes. Vast plains stretch across thousands of miles. These abyssal plains are among the flattest places on Earth. Fine sediment settles there slowly over millions of years, creating silent underwater deserts. Elsewhere, towering underwater cliffs descend into trenches. Submarine canyons carve through continental edges. Some underwater canyons are larger than the Grand Canyon itself. Entire mountain ranges rise through darkness. Volcanoes erupt unseen beneath the sea, and deep cracks in the earth release superheated water from within the planet. These are hydrothermal vents, one of the strangest discoveries ever made in the ocean. Before their discovery in the 1970s, scientists believed sunlight was necessary for complex ecosystems to exist. But around hydrothermal vents, life evolved without sunlight entirely. The water emerging from these vents can become extraordinarily hot, heated by magma beneath the seafloor. Minerals pour upward into the freezing ocean, forming towering black structures, sometimes called black smokers. Around them, entire ecosystems thrive. Giant tube worms, strange crabs, shrimp without functioning eyes, bacteria feeding on chemicals rising from the earth itself. Instead of relying on sunlight, these organisms survive through chemosynthesis, using chemical energy from the planet's interior. It was one of the most profound discoveries in modern biology because it changed the human understanding of where life can exist. If ecosystems could survive in darkness beneath crushing ocean pressure, perhaps life might also exist beneath the frozen oceans of distant moons, places like Europa, orbiting Jupiter, or Enceladus, orbiting Saturn, worlds covered in ice, with hidden oceans below. The deep sea, therefore, became more than an earthly mystery. It became a clue about the universe itself. And even now, scientists continue discovering new species in the ocean depths, creatures unlike anything previously imagined. Some appear delicate and almost transparent. Others resemble ancient predators from another age. There are fish with glowing lures extending from their heads, octopuses that drift like living fabric, jellyfish carrying long, luminous tendrils through darkness. In many cases, these species evolved in isolation for millions of years. The deep ocean became their hidden world, a place humans entered only recently. In fact, for most of history, humans had almost no idea how deep the ocean truly was. Ancient sailors sometimes lowered weighted ropes into the water to estimate depth. But beyond coastal regions, the sea often exceeded the length of their lines. The bottom simply vanished into darkness. Some cultures imagined underwater realms beneath the earth. Others believed giant creatures lived below, holding power over storms and disasters. And even after the rise of modern science, mapping the seafloor remained extraordinarily difficult. The ocean hides itself well. Water absorbs sound, bends light, distorts visibility, and crushes ordinary machines under pressure. The deeper humans traveled, the harder exploration became. In the 20th century, specialized submarines finally allowed descents into the deepest regions of the sea. One famous descent occurred in 1960. Two explorers aboard a vessel called the Trieste descended into Challenger Deep, nearly 7 miles beneath the surface. The journey downward took hours. As the submersible sank, sunlight disappeared completely. Outside the vessel, the ocean became entirely black. At those depths, the pressure against the craft became immense. The metal structure creaked constantly under strain. And yet, when they finally reached the bottom, they discovered life there. Not monsters, not empty darkness, but living organisms surviving in silence at the deepest known place on Earth. Even now, very few humans have ever visited those depths. Far more people have traveled into space, which means there are regions of the moon mapped more clearly than parts of our own oceans. And perhaps that is part of what makes the sea feel timeless. Even in the modern world, there are still places on Earth where mystery remains. For most of human history, the ocean represented the edge of the known world. People settled beside it, traveled across it, depended on it for food and trade, and feared it deeply at the same time. Because, unlike forests or deserts, the sea could change without warning. A calm horizon could become violent within hours. Storms rose suddenly over open water. Waves towered above wooden ships. Winds carried sailors far from land. And beneath everything, there was always the awareness of depth. The feeling that below the hull, the world dropped away into darkness. Ancient civilizations often viewed the ocean as something alive, not merely water, but a force with intention. In Greek mythology, Poseidon ruled the sea with unpredictable emotion, capable of calm or destruction without warning. In Norse stories, great serpents circled beneath the waters of the world. Across Polynesian cultures, master navigators crossed enormous distances by reading waves, currents, stars, birds, and subtle changes in the ocean itself. Many Pacific Islanders memorized patterns of swells traveling across open sea, allowing them to navigate thousands of miles without modern instruments. Long before satellites existed, humans learned to read the movement of the ocean almost like language, and still, despite all navigation and exploration, the sea remained dangerous. Because the ocean does not forgive mistakes easily, especially far from shore. Even today, The open ocean can feel strangely isolating. On land, humans evolved surrounded by stable reference points, trees, mountains, roads, buildings. But at sea, the horizon appears nearly identical in every direction. A person floating in open water may see nothing but sky and ocean stretching endlessly outward. No sense of scale, no visible landmarks, only movement. This vastness affects the human mind in unusual ways. Sailors throughout history described feelings of awe, fear, loneliness, and even hallucinations during long ocean voyages. Some experienced something called oceanic vertigo, a psychological disorientation caused by endless open space and repetitive motion. The sea can feel both peaceful and overwhelming at the same time, perhaps because humans instinctively understand how small they are compared to it. The Pacific Ocean alone covers more area than all the continents combined. Its deepest trenches descend farther downward than commercial airplanes fly upward. And, unlike mountains, whose peaks humans can at least observe from a distance, the deepest parts of the ocean remain hidden beneath miles of water. The sea conceals its scale. A person standing beside the ocean sees only the surface, but beneath that surface, entire worlds exist stacked vertically downward. The ocean is not one environment. It changes dramatically with depth. Near coastlines, sunlight supports coral reefs, forests of kelp, schools of fish, turtles, dolphins, and countless forms of visible life. Coral reefs are among the most biologically diverse ecosystems on Earth. Although they cover only a small percentage of the ocean floor, they support enormous numbers of marine species. Some reefs have existed for thousands of years, built slowly by tiny coral polyps, creating limestone skeletons over generations. These underwater structures eventually become massive living cities beneath the sea. Fish shelter among them. Predators hunt around them. Currents deliver nutrients through them. And yet, coral reefs are highly fragile. Changes in temperature, pollution, or ocean chemistry can damage ecosystems that required centuries to form. The ocean may appear eternal, but many marine systems exist in delicate balance. Farther from shore, the continental shelf eventually drops away, and this transition is dramatic. For a time, the seafloor slopes gradually downward. Then suddenly, the earth falls away into the deep ocean. This region is called the continental slope, a massive underwater descent marking the edge of continents themselves. Beyond it lies the abyss. Here, light fades rapidly, pressure increases constantly, and the familiar world disappears. Even sound behaves differently in the ocean depths. Water carries sound far more efficiently than air. Whale songs can travel astonishing distances through the sea. Some low-frequency whale calls may cross entire ocean basins. Blue whales, the largest animals ever known to exist, communicate across immense distances using deep resonant sounds. In the darkness of the ocean, sound becomes more important than vision. Many marine animals navigate through vibration and pressure changes. Some creatures detect movement from miles away. Others use forms of echolocation. Dolphins and certain whales emit sound waves and interpret returning echoes to understand their surroundings. In dark water, sound becomes a way of seeing. The deep ocean is therefore not silent in the way humans often imagine. It is filled with clicks, pulses, distant calls, shifting ice, underwater earthquakes, volcanic activity, and the slow movement of currents, a hidden acoustic world beneath the surface. And among the most mysterious sounds ever recorded in the ocean was one known simply as the bloop. In 1997, scientists monitoring underwater microphones detected an enormous low-frequency sound in the Pacific Ocean. The sound was so powerful it could be detected thousands of miles away. At first, some people speculated about unknown sea creatures of impossible size. Others imagined volcanic events, underwater landslides, or something entirely unexplained. Over time, scientists concluded the sound most likely came from massive ice movements deep in Antarctic waters. But for a period of time, the mystery captured the imagination of people around the world. Because the ocean still feels capable of hiding things. And in truth, many discoveries continue emerging from the sea even now. Shipwrecks lost for centuries remain preserved in darkness. Ancient trade routes lie scattered across the sea floor. Entire aircraft, cities, statues, and forgotten objects rest beneath water across the planet. The ocean became a vast archive of human history. In some deep regions, cold temperatures and low oxygen slow decay dramatically. Wooden ships, centuries old, may still remain partially intact. Artifacts survive quietly in darkness where sunlight never reaches. Time itself seems to move differently underwater, and perhaps nowhere is this feeling stronger than near the poles. The Arctic and Antarctic oceans are among the harshest environments on Earth. Sea ice expands across enormous distances during winter, transforming entire oceans into frozen landscapes. Beneath the ice, the ocean continues moving silently. In Antarctica, some ice shelves are hundreds of feet thick. Below them lies black, freezing water extending into darkness. Creatures survive there that evolved specifically for these conditions. Fish with natural antifreeze proteins in their blood. Translucent organisms drifting beneath ice. Massive squid moving through cold, abyssal depths. The giant squid itself remained mysterious for centuries. Sailors told stories about enormous tentacled creatures attacking ships. Most scientists dismissed such accounts as exaggeration. Yet giant squid turned out to be real. Massive animals capable of reaching extraordinary lengths. Living primarily in deep ocean environments difficult for humans to observe. For much of history, the ocean blurred the line between myth and reality because strange discoveries kept emerging from it, and still do. Even today, new marine species are discovered every year. Some live so deep that humans encounter them only rarely. Others appear briefly in fishing nets before vanishing again into darkness. There are fish with transparent heads, creatures that survive beside volcanic vents, animals producing blue or green light from their bodies, and organisms that may live for hundreds of years in cold, deep water. Certain deep sea corals are believed to be thousands of years old, alive before many human civilizations even existed. The ocean, therefore, contains not only immense space, but immense time, ancient ecosystems, ancient currents, ancient life forms, a hidden continuity beneath human history. While nations changed, wars were fought, cities expanded, and technologies transformed civilization, the deep ocean remained largely unchanged. Dark, cold, and patient, far below the movement of the modern world, far beneath the movement of ships, beneath storms crossing the surface, beneath the migrations of whales and the drifting of ice. The deep ocean continues, almost untouched by the rhythms of human life. There are regions of the sea where sunlight has never reached, where no human being has ever directly seen the landscape with their own eyes. And in many of these places, the pressure becomes so immense that ordinary materials begin to fail. At sea level, humans live beneath the weight of the atmosphere, but underwater, pressure increases rapidly with depth. for roughly every 10 meters descended. The pressure rises again by the time a person reaches only 100 feet underwater. The force pressing against them is already several times greater than what humans experience on land. At the deepest parts of the ocean, the pressure becomes almost unimaginable. A single square inch may experience thousands of pounds of force. Submarines designed for these environments require incredibly thick hulls, special materials, and precise engineering simply to avoid collapsing inward. Even tiny weaknesses become dangerous. During deep-sea expeditions, engineers sometimes describe the ocean pressure as relentless, an invisible weight pressing from every direction at once. And yet, life evolved there anyway. Not despite the pressure, but within it. Deep-sea organisms are not resisting their environment the way humans would. Their entire biology developed around it. Many creatures living in abyssal regions possess soft, flexible bodies because rigid, air-filled structures would collapse under extreme pressure. Others lack swim bladders entirely. Some species evolved slow metabolisms that require very little energy, allowing them to survive in regions where food remains scarce for long periods of time. Certain deep-sea animals may eat only occasionally, waiting patiently in darkness for opportunity to drift past them. In the abyss, energy cannot be wasted. Even movement becomes careful. And because sunlight cannot penetrate these depths, many creatures no longer rely heavily on vision. Some have tiny, reduced eyes. Others evolved enormous sensitive eyes, capable of detecting faint, bioluminescent flashes. And some creatures appear almost alien to human perception because they adapted to an environment so completely unlike the world above. The anglerfish became one of the most famous examples. Drifting through darkness with a glowing lure extending from its head, it uses light itself as a trap. Smaller creatures approach the glow in the black water and suddenly disappear into rows of sharp, curved teeth. But even stranger adaptations exist deeper still. Some fish produce red bioluminescent light, a wavelength difficult for most deep-sea organisms to detect. This effectively allows them to illuminate prey without easily revealing themselves. Others possess transparent heads or organs that glow through their skin. Some deep-sea jellyfish create pulses of blue light when disturbed. Brief, luminous explosions drifting silently through darkness. And in a world without sunlight, bioluminescence became extraordinarily common. It is estimated that the majority of deep-sea organisms may produce some form of light. The ocean, therefore, contains enormous hidden constellations, not in the sky above, but suspended through darkness below. Tiny living lights blinking through black water. Signals without sound. Far from the surface. Time itself also begins to feel different. Many deep ocean environments change extremely slowly. Temperatures remain stable. Sunlight never alters the landscape, and seasons barely exist at all. Some animals living there grow very slowly and live surprisingly long lives. The Greenland shark, which inhabits cold northern waters, is believed to be among the longest living vertebrates on Earth. Some estimates suggest individuals may survive for centuries. There may be sharks swimming in the ocean today that were already alive before modern industrial civilization began, before electricity spread through cities, before airplanes, before many modern nations existed. The deep sea preserves ancient rhythms, and this ancient quality appears not only in individual animals, but in entire species. Certain organisms living in the ocean today resemble forms of life that existed hundreds of millions of years ago. The horseshoe crab, often called a living fossil, has changed remarkably little across immense stretches of evolutionary time. Long before dinosaurs appeared, ancient marine creatures already inhabited Earth's oceans. In fact, life itself may have begun in the sea. Scientists believe the earliest living organisms emerged billions of years ago in ancient oceans, perhaps near hydrothermal vents, or within shallow, mineral-rich waters along the young Earth's surface. At that time, there were no forests, no birds, no mammals, no human beings, only oceans beneath unfamiliar skies. For most of Earth's history, all life existed exclusively underwater. The sea was the original world of life on this planet. Even human bodies still carry reminders of that distant connection. The salt concentration within human blood resembles the chemistry of ancient seawater. Before birth, human infants develop suspended in fluid environments, and the rhythmic sound of waves often produces calming effects within the human nervous system, perhaps because the ocean feels ancient and familiar at the same time. A memory older than conscious thought. And yet, despite humanity's long relationship with the sea, the ocean can still become extraordinarily destructive. Some of the most powerful forces on Earth emerge from water. Hurricanes gather energy from warm oceans. Tsunamis carry entire walls of seawater across enormous distances. Underwater earthquakes reshape coastlines, Massive rogue waves occasionally appear far larger than surrounding seas. For centuries, sailors described enormous isolated waves rising suddenly from open water. Many scientists initially doubted these stories, but modern measurements eventually confirmed that rogue waves are real. Under certain conditions, ocean waves can combine together into towering walls of water capable of damaging even large ships. The sea remains dynamic, powerful, and unpredictable. Beneath the surface, tectonic plates continue moving. Volcanoes erupt underwater. Entire islands slowly form and disappear over geological time. The Atlantic Ocean itself continues widening gradually as tectonic plates drift apart, only by inches each year, but continuously. The earth beneath the ocean is not still. It is alive with motion. And nowhere is this more visible than along the Ring of Fire, a vast region surrounding much of the Pacific Ocean, where tectonic activity remains especially intense. Many of Earth's largest earthquakes and volcanic eruptions occur there. Deep ocean trenches, volcanic island chains, and shifting crust all connect through these immense geological systems. The Pacific Ocean became the deepest ocean partly because of these powerful tectonic interactions. Its sea floor contains many of the deepest trenches ever discovered. And despite all modern technology, the true shape of the seafloor remained surprisingly unknown until relatively recently. For most of history, humans could only guess what existed below. Even today, mapping the ocean floor remains enormously difficult. Satellites can estimate broad seafloor structures indirectly by measuring subtle changes in sea surface height caused by gravity. But detailed mapping often requires ships slowly scanning the ocean using sonar, sending sound downward and measuring echoes returning from the seafloor. Considering the sheer size of Earth's oceans, this process takes enormous time. Large regions remain only partially mapped even now. There are underwater mountains, canyons, ridges, and volcanic structures humans have barely studied. Possibly ecosystems never directly observed. The ocean still contains frontiers, and perhaps that feeling is increasingly rare in the modern world. On land, most places are mapped, photographed, connected, and documented. But beneath the sea, there are still enormous hidden spaces, dark regions where the planet remains mysterious, places where ancient geological forces continue shaping the earth quietly beneath miles of water, unseen by almost everyone above. Far below, the busy routes of ships and cargo vessels, beneath submarines, beneath fishing boats, beneath storms, visible from satellites orbiting above the Earth. The deepest parts of the ocean continue in near total darkness, a darkness so complete that human vision becomes almost meaningless there. If a person descended deep enough into the abyss without artificial light, there would eventually come a point where the eyes could no longer distinguish anything at all. No horizon, no movement, no shape. Only blackness extending in every direction. And yet, despite this absence of sunlight, the deep sea is not inactive. It is constantly moving. Cold currents drift slowly across the seafloor. Sediment settles downward through the water column. Organisms migrate vertically through darkness each night, and tectonic forces continue reshaping the earth below. Some of the largest migrations on the planet occur invisibly beneath the ocean surface. Every evening, billions of small marine organisms rise upward from the depths towards shallower waters. Then, before sunrise, they descend again into darkness. This process is called vertical migration, and astonishingly, it may represent the largest animal migration on Earth by total biomass. Tiny creatures moving silently through black water every single day. Most humans never realize it is happening. Many deep-sea organisms avoid surface waters during daylight because predators can see them more easily there. At night, under darkness, they rise to feed, then retreat downward again before sunrise returns. The ocean, therefore, contains daily rhythms, even in places sunlight never directly reaches. Life responds to cycles occurring far above. And the farther scientists explored the sea, the more they realized how interconnected the oceans truly are. Nutrients from deep waters eventually rise upward through currents. Tiny plankton near the surface support fish populations. Fish support larger predators. Whales transport nutrients across enormous distances. Even the deaths of large marine animals influence deep-sea ecosystems. When a whale dies in the open ocean, its body slowly sinks downward through the water. This event is called a whale fall, and in the deep sea, a whale fall becomes an entire ecosystem. First come scavengers, sharks, hagfish, and other organisms feeding on soft tissue. Later, smaller creatures consume what remains. Eventually, even the bones become habitats for specialized bacteria and marine life. A single whale carcass may support deep-sea ecosystems for years. In the abyss, Nothing is wasted easily. Life adapts around rarity. And perhaps nowhere is rarity more important than food itself. The deeper ocean contains far less energy than sunlit waters near the surface. This scarcity shapes everything. Deep sea predators often evolved enormous jaws and expandable stomachs because meals may be infrequent. Some organisms consume almost anything they encounter. Others drift passively to conserve energy. There are regions where creatures survive in such low energy environments that movement itself becomes minimal. The deep ocean rewards efficiency, patience, stillness, and yet, despite these harsh conditions, some deep sea organisms became enormous. This phenomenon is known as deep sea gigantism. Certain animals living in cold, deep waters grow far larger than similar relatives in shallow seas. Giant isopods, massive sea spiders, enormous squid. Scientists continue debating exactly why this occurs. Cold temperatures, high pressure, slow metabolisms, and oxygen availability may all contribute. But regardless of the cause, the results often appear strange to human eyes. Creatures resembling ordinary animals from shallow water, but transformed into enormous pale versions, drifting through darkness. The giant squid became one of the most famous examples. For centuries, stories of enormous tentacled creatures circulated among sailors. Many people assumed the tales were exaggerated, but eventually evidence accumulated. Massive squid do exist. Animals capable of reaching remarkable lengths, with eyes among the largest in the animal kingdom. Their enormous eyes likely evolved to detect faint movement and light in deep, dark water, especially the approach of predators like sperm whales. Sperm whales themselves are extraordinary deep divers. They descend thousands of feet beneath the surface, searching for squid in darkness, holding their breath for astonishing lengths of time, navigating primarily through sound. When sperm whales dive, they leave behind the bright world near the surface and descend into pressure and darkness where humans rarely travel. And still, even these great animals explore only portions of the ocean's depths. The sea extends farther downward still, in some trenches. The environment becomes so extreme that scientists once doubted complex organisms could survive there at all. Yet, life persists even in Hadal zones. The deepest ocean regions named after Hades, the underworld of Greek mythology, tiny amphipods, sea cucumbers, microbial life. organisms adapted to crushing pressure beyond ordinary human imagination. The existence of life in such environments transformed scientific thinking, because if life could survive in darkness beneath immense pressure on Earth, perhaps life might survive in similarly extreme environments elsewhere in the universe. Some scientists believe oceans may exist beneath the icy crusts of distant moons. Europa, orbiting Jupiter, is believed to contain a global ocean beneath thick ice, possibly containing more water than all Earth's oceans combined. Enceladus, a moon of Saturn, also appears to contain subsurface oceans. Jets of water vapor erupt from cracks in its frozen surface. And because hydrothermal activity may exist there as well, scientists consider these worlds possible places where extraterrestrial life could exist. The deep ocean therefore changed not only marine science, but humanity's broader understanding of life itself. Earth's abyss became a model for environments once considered impossible. And still, the oceans continue revealing unexpected discoveries. Sometimes entire ecosystems emerge where scientists never predicted them. In recent decades, researchers discovered vast coral systems in deep, cold waters, far from tropical reefs. Unlike brightly colored shallow water corals, these deep corals survive without sunlight, growing slowly through darkness over centuries. Some structures may be thousands of years old. Ancient living architecture hidden beneath black water and scattered across the seafloor. There are also immense fields of manganese nodules, dark mineral-rich rocks forming extremely slowly over millions of years. Some companies and governments have become increasingly interested in deep-sea mining because these nodules contain metals used in modern technologies. But many scientists warn that disturbing deep-sea ecosystems could damage environments humans barely understand. The ocean floor is not empty wasteland. It contains living systems that evolved across immense spans of time. Some species may exist nowhere else on Earth, and because many deep-sea organisms grow slowly, recovery from disruption could require centuries or longer. The deep sea therefore raises difficult questions about exploration and responsibility. How should humans interact with environments they barely understand? What happens when technology advances faster than knowledge? The ocean often forces humanity to confront its own limits. Even with satellites, robotics, and advanced science, much remains uncertain beneath the waves. And perhaps uncertainty itself is part of what gives the sea its emotional power. The ocean reminds humans that the world is still larger than complete understanding. There are still hidden places, still unknown species, still unexplored landscapes beneath the surface of the earth. Even now, as cities glow at night, as airplanes cross continents, as billions of people move through modern life, the deep ocean continues quietly below. Dark currents drifting through trenches, bioluminescent creatures pulsing with cold blue light, ancient ecosystems surviving beneath miles of water, and vast, unseen landscapes stretching outward through silence. The deeper scientists studied the ocean, the more they realized that the sea does not simply surround the continents. In many ways, the continents exist within the influence of the sea. The oceans shape coastlines constantly. Waves grind rock slowly into sand. Currents move sediment across enormous distances. Storms reshape beaches overnight. Even massive cliffs eventually surrender to water over enough time. The sea is patient, and patience is one of the most powerful forces on earth. A single wave may seem insignificant, but over centuries, over millennia, the repeated movement of water can carve caves into stone, hollow coastlines, and reshape entire landscapes. Many places humans consider permanent are only temporary forms beside the ocean. Shorelines migrate. Islands appear and disappear. River deltas expand outward and collapse again. Sea levels rise and fall across geological ages. At the height of the last ice age, vast amounts of Earth's water were trapped in continental glaciers. Sea levels were dramatically lower than they are today. Entire land bridges connected regions now separated by ocean. Humans once crossed from Siberia into North America, across exposed land now submerged beneath the Bering Sea. Ancient coastlines existed far from modern shores, and as glaciers eventually melted, the oceans rose again, slowly swallowing landscapes that had once remained dry. There may be countless traces of ancient human settlements now hidden beneath the sea, especially near former coastlines, because humans throughout history often settled near water. The ocean fed civilizations, connected trade routes, and supported agriculture through rivers and rainfall. Yet, over immense spans of time, the same sea gradually reclaimed some of those places. Legends of lost cities beneath the ocean appear across many cultures, stories of drowned kingdoms, sunken temples, and vanished coastlines. Some of these stories were likely inspired by real environmental change remembered across generations, because the ocean has always moved, and humans have always noticed. Even now, entire island nations face uncertainty as global sea levels continue rising. The sea is never completely still in geological time. It advances, retreats, reshapes, transforms, and the ocean influences not only the edges of continents, but the atmosphere above them. Many of the planet's most powerful storms begin over warm ocean water. Hurricanes, typhoons, and cyclones all draw energy from the sea. Warm water evaporates upward into the atmosphere, transferring heat and moisture into enormous rotating systems. The storm grows stronger as long as it remains above warm water. Some hurricanes become so large they can be seen clearly from space. Massive rotating structures larger than entire countries. Yet at their center often lies the eye, a strangely calm region surrounded by violent motion. For ancient sailors, storms at sea could feel almost supernatural. Towering waves, screaming wind, lightning across black water, ships disappearing beneath darkness. Even modern vessels remain vulnerable to the ocean under severe conditions because water possesses tremendous force. A cubic yard of seawater weighs more than many small cars. When waves move across open ocean, they carry enormous energy through the water. Most waves form from wind, transferring energy into the sea surface. The stronger and longer the wind blows, the larger waves may become. In open oceans, swells generated by distant storms can travel thousands of miles. A calm beach may receive waves created by weather systems far beyond the horizon. The ocean, therefore, connects distant regions invisibly. Storms in one part of the world may influence coastlines far away days later. And beneath these moving surfaces, the sea contains layers and currents flowing in different directions simultaneously. The ocean is never truly motionless. Even in darkness, water continues circulating across the planet. Some currents descend into the deep ocean near polar regions because cold water becomes denser. Others rise slowly upward, carrying nutrients from below. This upward movement, called upwelling, supports some of the richest marine ecosystems on Earth. Nutrients from the deep feed plankton near the surface, which support fish populations, seabirds, whales, and countless other organisms. Entire food chains depend on these hidden ocean movements. And because the sea stores such immense amounts of heat, Changes in ocean circulation can influence global climate itself. Phenomena like El Niño and La Niña emerge partly from changing ocean temperatures and atmospheric interactions across the Pacific Ocean. These events can alter rainfall, drought, storms, and temperatures across large portions of the world. Farmers, fisheries, ecosystems, and economies may all feel the effects of changes occurring far out at sea. The ocean quietly influences human civilization in ways many people rarely consider. Even oxygen itself, a significant portion of the oxygen humans breathe, originates from marine photosynthetic organisms. Tiny, drifting plankton producing oxygen beneath sunlight. Invisible life supporting visible civilization. And deep below those sunlit waters, the abyss continues. Cold and dark beneath everything above. The ocean is often divided into vertical zones. Near the surface lies the epipelagic zone, where sunlight supports abundant life. Below that comes the mesopelagic zone, sometimes called the twilight zone. Light still exists there faintly, but not enough for photosynthesis. Creatures in this region often possess large eyes, silvery bodies, or bioluminescent organs. Deeper still lies the bathypelagic zone, the midnight zone, permanent darkness. Then farther downward come the abyssal plains, and finally the Hadal trenches, the deepest parts of the Earth's oceans. Each layer contains different pressures, temperatures, and forms of life. The ocean, therefore, resembles a vertical world stacked downward through darkness, almost like descending through entirely different planets. And because humans naturally live near the topmost layer, the lower regions remained mysterious for most of history. In ancient times, many people believed the ocean depths connected somehow to the underworld. Greek myths spoke of vast waters surrounding the world. Norse cosmology imagined cosmic seas encircling existence itself. Across cultures, deep water became associated with mystery, chaos, creation, and the unknown. Perhaps because humans instinctively recognize how little they can control the sea. Even advanced civilizations remain vulnerable to it. Tsunamis generated by underwater earthquakes can cross entire oceans. When tectonic plates shift suddenly beneath the sea floor, massive volumes of water may move outward in every direction. In deep water, a tsunami wave may pass almost unnoticed by ships, but near coastlines, The wave slows and rises dramatically. The energy compresses upward. Walls of water surge inland with devastating force. Throughout history, coastal communities have experienced sudden destruction from the sea, and yet humans continue returning to coastlines again and again, because oceans also provide abundance. Fishing supported civilizations for thousands of years. Trade routes crossing oceans connected distant cultures. Exploration expanded through maritime navigation. Entire empires rose through control of sea routes. The ocean became both pathway and barrier, danger and opportunity together. And over time, humans gradually learned how to travel farther across open water. Ancient Polynesian navigators crossed enormous regions of the Pacific using stars, wave patterns, cloud formations, and bird behavior, without compasses, without engines, without modern maps. They memorized the sea itself. In the Arctic, Inuit communities learn to survive within harsh marine environments shaped by ice and seasonal migration. Mediterranean civilizations developed complex trade systems across interconnected seas. The Vikings crossed cold northern oceans in wooden ships, guided partly by stars and currents. For much of history, the sea represented uncertainty. Voyages carried enormous risk. Storms, disease, navigation errors, starvation. A ship disappearing beyond the horizon might never return. And beneath every voyage remained the awareness of depth. Miles of dark water below fragile wooden hulls. Unknown creatures beneath. Invisible currents moving through darkness. The ocean carried mystery in a way few environments could, because so much of it remained hidden. Even now, despite satellites and sonar, the deep sea preserves that feeling. There are trenches humans have visited only a handful of times. Species observed once and never seen again. Unmapped volcanic systems. Ancient ecosystems beneath Antarctic ice. And perhaps millions of marine organisms still undiscovered. The ocean remains one of the last great unknown regions on Earth, not because humans never tried to understand it, but because the sea is vast beyond ordinary intuition, a world covering most of the planet, descending miles into darkness, older than humanity itself, and still continuing quietly beneath the surface tonight. As night falls across the oceans, the surface of the sea begins to change. Winds soften in some regions, temperatures cool, and darkness spreads outward across the water. From the perspective of space, the oceans at night appear immense and nearly endless. Only scattered lights from ships interrupt the darkness. Below those distant lights, the sea continues moving through ancient rhythms unchanged by human schedules or borders. Currents drift slowly through trenches. Plankton rise toward the surface. Whales travel through black water, guided by sound. And in many places, the ocean at night becomes more alive than during the day. Creatures hidden in the depths begin ascending upward under cover of darkness. Jellyfish drift near the surface. Small fish follow clouds of plankton. Predators rise behind them. The boundary between shallow and deep water becomes active with movement. An enormous hidden migration unfolding silently every evening across the planet. For humans observing from boats, the nighttime ocean often feels entirely different from the daytime sea. Distances become difficult to judge. The horizon disappears. The water reflects only fragments of moonlight or stars. And beneath the surface, nothing can be seen at all. Many sailors throughout history described the nighttime ocean as strangely psychological, a place where imagination becomes powerful. Without visible landmarks, the mind begins filling darkness with possibilities. Perhaps this is one reason the sea inspired so many myths across cultures, because, unlike mountains or forests, the ocean conceals almost everything beneath its surface. Humans naturally fear environments they cannot fully perceive. And yet, the sea also creates moments of extraordinary beauty. In certain regions, waves glow blue at night from bioluminescent plankton disturbed by movement. Each crashing wave produces cold blue light. Fish leave glowing trails behind them. Boats carve luminous patterns through dark water. It can appear almost unreal, as though stars themselves have fallen into the ocean. Bioluminescence evolved many different times in marine life, and scientists believe it serves numerous purposes: communication, camouflage, defense, attraction, hunting. Some squid eject glowing clouds into the water to confuse predators. Certain fish use light-producing organs to erase their silhouettes from below, making them harder to detect against faint light from the surface. Others create flashing patterns unique to their species. The deep sea became a world where life learned to manipulate light itself. Because in darkness, Light becomes power, and despite the beauty of these adaptations, survival in the deep ocean remains difficult. Food scarcity shapes nearly everything. Some creatures wait motionless for long periods, conserving energy. Others drift with currents rather than actively swimming. Many deep-sea predators rely on ambush, sudden bursts of movement in otherwise still darkness. There are fish capable of swallowing prey nearly their own size because opportunities to eat may be rare. Some species survive by consuming marine snow alone, tiny particles drifting downward endlessly from upper waters. Even the ocean floor receives this slow snowfall constantly, fragments of life descending through darkness over millions of years. Layer upon layer settled across the seafloor. Mud, microscopic shells, volcanic ash, organic material. In some regions, these sediments accumulated into thick geological archives. Scientists studying ocean cores can examine these layers almost like pages of history, each layer preserving information about ancient climates, extinction events, volcanic eruptions, and changes in Earth's atmosphere. Tiny marine organisms trapped within sediments reveal temperatures from oceans that existed long before humans. The deep sea, therefore, remembers the history of the planet in physical form, a silent archive beneath miles of water. And sometimes the ocean preserves human history as well. Shipwrecks resting in darkness often remain astonishingly intact. Cold temperatures and low oxygen slow decay in certain deep environments. Ancient amphorae, wooden hulls, warships, cargo vessels. Entire chapters of civilization lie scattered across the seafloor. Some ships disappeared centuries ago and were found only recently, frozen almost in time beneath darkness. The Titanic itself rests deep within the North Atlantic Ocean, more than 12,000 feet below the surface. At that depth, the pressure is immense, the water near freezing, and sunlight entirely absent. When explorers first located the wreck in 1985, many people were struck not only by the tragedy, but by the strange stillness of the sight. A vast ship resting silently in darkness, as though the ocean had slowly absorbed it into another world. Over time, marine organisms and corrosion continue reshaping the wreck. Even steel eventually yields to the sea. The ocean is patient with everything, and patience becomes especially visible through geological time. The continents themselves were once arranged differently, hundreds of millions of years ago, Earth's land masses formed ancient supercontinents. Oceans opened and closed as tectonic plates shifted slowly across the planet. Entire seas disappeared over time. Others formed where none existed before. The Atlantic Ocean itself did not always exist in its current form. Long ago, North America and Europe were connected. As tectonic plates gradually separated, new ocean crust formed between them. Very slowly, the Atlantic widened. It continues widening even now, only by inches each year, but continuously. If humans could watch Earth over millions of years in accelerated motion, the planet would appear alive. Continents drifting, oceans changing shape, mountains rising and eroding away. Nothing remaining fixed forever. And beneath all of it, the ocean persists, older than human civilization, older than humanity itself. In many ways, the sea became the background environment of life on Earth. For billions of years, before animals walked on land, the oceans already existed. Ancient microbial life drifted through primitive seas beneath unfamiliar skies. Over immense spans of time, evolution transformed those early organisms into increasingly complex forms. Fish eventually appeared. Then plants and animals gradually colonized land. Yet even after life spread across continents, the oceans remained central to the planet's systems, and they continue influencing life every moment. The oxygen in each breath, the climate surrounding civilizations, the rainfall feeding rivers, the currents shaping weather, all remain tied to the sea. And still, despite how deeply connected humans are to the ocean, most people will never directly experience its deepest environments. The abyss remains physically inaccessible to ordinary human life. To descend there requires extraordinary technology, specialized submersibles, pressure-resistant materials, careful engineering. And even then, the ocean allows only brief visits. Human beings cannot remain naturally within the deep sea. We enter temporarily, observe briefly, and return again to the surface world. Perhaps that is why the deep ocean still feels almost dreamlike. A hidden realm existing beneath ordinary awareness. Dark landscapes few eyes have seen. Creatures producing their own light in endless night. Ancient trenches descending farther than mountains rise. Silent volcanic systems shaping the earth from below. and currents moving slowly through darkness, as they have for ages beyond human memory. And so, after all the centuries of sailing, all the maps, all the sonar scans, all the satellites orbiting far above the Earth, the ocean still remains partly unknown. Even now, human beings have walked upon the moon, sent machines beyond the edge of the solar system, and filled the night sky with orbiting technology. Yet, beneath the surface of our own planet, there are still places almost entirely unexplored. Dark valleys deeper than mountains are tall, trenches hidden beneath miles of water, ecosystems surviving in silence without sunlight. The sea continues holding mysteries quietly below, and perhaps it always will, because the ocean is too vast to fully absorb into human understanding all at once. Too deep, too old, too alive with movement. The oceans connect every continent, shape every climate, carry storms across the world, and support life in ways most people never directly see. Tiny, drifting plankton produce oxygen beneath sunlight. Deep currents redistribute heat across the planet. Whales migrate silently through black water. Ancient volcanic systems continue reshaping the seafloor. And somewhere tonight, far beneath the surface, cold water is still drifting through trenches untouched by light. The deep ocean does not sleep in the way humans do. It continues endlessly. Currents move, sediment falls, creatures rise and descend through darkness. Bioluminescent flashes appear and vanish again. A hidden world moving beneath the visible one. And perhaps part of what makes the ocean feel so emotional to human beings is that it reminds us how much still exists beyond ordinary awareness. Modern life often feels loud, bright, crowded with information, but the deep sea remains distant from all of that. Miles beneath the surface, there are no cities, no advertisements, no traffic, no human schedules, only darkness, pressure, cold, and time. Immense time. Some deep ocean waters began their journeys centuries ago. Certain corals living in darkness may have started growing before entire modern nations existed. Sediments resting on the seafloor preserve records from climates millions of years old. The ocean carries memory differently than humans do. Slowly, quietly, in layers. And perhaps that slowness is why the sea so often calms the human mind. Waves repeat endlessly. Tides rise and fall. Currents drift steadily onward. The ocean moves without urgency. Even storms eventually pass across it. And beneath those storms, the deeper waters remain comparatively still. There is something strangely comforting about that. The idea that below the surface turbulence, there exists another quieter world, a colder, darker, slower world, continuing patiently beneath everything above. Throughout history, people stood beside the ocean searching for meaning. Sailors watched distant horizons, wondering what lay beyond them. Philosophers compared the sea to the unconscious mind, vast and difficult to fully understand. Poets wrote about waves, tides, and endless water stretching beyond sight. And even now, humans continue returning to the ocean when searching for stillness, because standing beside the sea often changes the scale of thought itself. The horizon widens, the mind slows, ordinary worries begin feeling smaller against something so ancient and immense. The ocean existed before human civilization, before languages, before memory, long before the first person ever stood beside a shore and listened to waves moving through darkness, and long after modern cities change and disappear, the sea will likely continue. Currents drifting silently around the planet, storms crossing open water, deep trenches resting in permanent night, whales calling through black oceans, ancient tectonic plates still shifting beneath the seafloor, the earth breathing slowly through water, and somewhere far below the surface tonight, in darkness untouched by sunlight, small living lights continue pulsing softly through the abyss. Tiny blue flashes appearing, disappearing, drifting slowly through black water older than human history. As cold currents move patiently across the seafloor, as marine snow continues falling through darkness, as unseen creatures glide silently beneath miles of ocean, and above them, far above, moonlight reflects gently across the surface of the sea. Soft waves rising and falling, rising and falling. The endless, quiet rhythm of water moving through the night until the horizon softens and the ocean becomes only darkness and distance and slow drifting motion. Far below, the deep sea continues quietly onward, unhurried, ancient, endless,